In this video, we're going to look at a problem in which you are asked to solve a right triangle. So you'd be given a triangle and it just says solve it. And when you are asked to solve a right triangle, there is a specific meaning behind that. And so when you solve a right triangle, it means you're going to find all the measures of the sides and angles of a right triangle. So we want to find all the measures of the sides and angles in a right triangle. All right, now the way this gets set up, it basically means you need to find three things. So in order to solve a right triangle, you have to be given three things. So there's two situations. Situation number one, you're always given a right angle, so you have the right angle, and then you're given another side and another angle. So that could be one situation. Situation number two, you have your right angle, and then you're giving another side and another side. So that's basically the two situations when it comes to solve a right triangle. You're given one of these two, and then you got to find everything else. So let's go ahead and look at an example. Let's solve a right triangle with angle B equal to 42 degrees and side C equal to 50. Okay, so there's our problem. We want to solve a right triangle with this bit of information. All right, now when you do solve a right triangle, there's this understanding that the triangle is always the same as far as the lettering goes. So we draw our right triangle. Okay, here's our right angle. And then we always have A, B, and C. Now, which one of these is A and B actually doesn't matter, but C always has to be that right angle. So kind of keep that in mind. Within that question, we know that C is the right angle. And then the side opposite A is side A, the side opposite B is side B, and the side opposite C is side C. Okay, so you do have to know this particular situation when it comes to solving a right triangle. When the questions are asked, they kind of assume you know that. All right, let's put on all of our information. We know that angle B is 42 degrees. And side C is 50. All right, so here's a situation where we're given a right angle, a side, and an angle. We have a right angle, a side, and an angle. And so we've got to find the other three parts. We have to find angle A, and side B. Right, there's one other part about this, and that is to get the other parts of the triangle, you have to always go back to the original information. So you have to kind of keep that in mind. Right, the easiest thing to do is let's go ahead and find angle A. Now, the quickest way to find angle A is there was a theorem back in geometry. It's actually pretty easy to see. It's logical that if you have a right triangle, the sum of the acute angles must be 90 degrees. I mean, even if we did this, the sum of the interior angles of a triangle is 180. So if we had the measure of angle A plus 42 degrees plus 90 degrees equals 180. Notice we always subtract 90, so you get the measure of angle A plus 42 degrees equals 90 degrees. So you can always start with this particular first step, but I actually usually go ahead and remember that the sum of the acute angles in a right triangle adds up to 90. It just kind of makes it a little bit quicker. Anyways, we subtract 42 from both sides, and the measure of angle A equals 48 degrees. All right, there we go. So that's our first thing. Now let's find A. Now remember, we got to go back to the original information. Don't use that 48 degrees. Use the 42 and this 50. So relative to A, so 42, we have the adjacent and the hypotenuse. So that's cosine. So we would have the cosine of 42 degrees is the adjacent over the hypotenuse. So A is 50 times the cosine of 42 degrees. So A is going to be approximately equal to, let's go ahead and get out our calculators for that. 50 times the cosine of 42 is 37.16. Excellent. Okay, so we're starting to get our parts of the triangle. Now we need C. Or I mean B, I'm sorry. Okay, now again, we got to go back to the original information. I mean, just to clarify this, you know, this is approximately 37.16. So technically, if we wanted to find B, we could use the Pythagorean theorem. We have two sides of the triangle, we could get the third. But the point of these problems is to always go back to this original information and get that third piece. So we're not going to use that. We're going to go ahead and look at our 42 and the 50. So we have opposite, and that's the sign. It's the opposite, B over the hypotenuse, 50. So B is equal to 50 times the sine of 42 degrees. So B is approximately, let's see here, 50 times the sine of 42. And that is 33.46. Good. All right, the last thing you have to do is kind of organize your answer. So we're going to go ahead and organize our answer. We'll put the sides first. A is approximately 37.16. B is approximately 33.46. Do put this in alphabetical order. And then we'll do the angle. Measure of angle A equals 48 degrees. We put a box around that so it's a little bit easier to grade. And there you go. Good. Let's do another example of this. Let's solve a right triangle with A equal to 7 and B equal to 12. There we go. All right, so we create the exact same triangle. You'll always notice that when I do this, my triangles look the same no matter what. A, B, C, little a, little b, little c. So A is 7 and B is 12. All right, so in this case, it's case 2. We have a right angle and two sides. A right angle and two sides. All right, so let's go ahead and, I mean, it doesn't matter if you find C or angle A or angle B first, you know, whichever one you want to do, but I'm going to go ahead and find side C first. And so if we're given these two sides and we want the third side on a right triangle, we have to use the Pythagorean theorem. A squared plus B squared equals C squared. So we have 7 squared plus 12 squared equals C squared. Let's see here. So that's 49 plus 144 equals C squared. So what is that? 193 equals C squared. And then when we take the square root, C is approximately equal to, we're going to have to, the square root of 193 is 13.89. Good. All right, so we got that part. Now let's see if we can get angle A. That works. So relative to angle A, we have the opposite and the adjacent. So that's going to be the tangent. So the tangent of A is the opposite, which is 7, and the adjacent, which is 12. Now from this, we can automatically go to the measure of angle A equals the inverse tangent of 7 over 12. So the measure of angle A is going to be approximately, let's see here, so we're going to have the inverse tangent of 7 divided by 12, whoops, 30.26 degrees. Good. All right, one more part to go, B. And again, we got to go back to our original information. So looks like we're going to use another tangent ratio. So the tangent of B is the opposite, 12/7. So angle B, the measure of angle B, is going to equal the inverse tangent of 12/7. So that means the measure of angle B is going to be approximately equal to inverse tangent of 12 divided by 7, and that is 59.74 degrees. Good. Okay, let's write everything out. So C is approximately 13.89. The measure of angle A is approximately 30.26 degrees, and the measure of angle B is approximately 59.74 degrees, and we'll put a nice box around that. Okay, so there are two examples of solving a right triangle. Again, when you're solving a right triangle, you're basically giving three pieces of information. One of them, of course, is always the right angle. And then you just have to find the other three parts, and that just depends on what you're given.